Hi, hello everyone. So welcome to my channel. So in this video we are going to discuss the chapter Statistics of Class 10 APTS and NCERT boards. So it is also useful for all other competitive exams, right? So if you are new to this channel, so please subscribe the channel and watch the video till the end, and please share with your friends so that they also get benefited from this video, right? So this particular chapter Statistics has started from year 6th class with the title Data Handling, and you are still learning in your 10th class, right? So in this particular 10th class we are going to discuss the main points of statistics, the main tools of the statistics, so which are nothing but mean, median and mode for group data. So for group data we are going to find out these three things, right? So let us begin the video. So what we are having, so the word statistics is taken from the Latin word status, or Italian word stata, or Greek word statistics, so which means a political state. So that means this particular chapter statistics deals with the data, and it tells you the political state. So that is nothing but the position of the data. Next, Sir Ronald Fisher. So he is the father of statistics. So he has played a major role in the development of new theories of statistics, right? Next, moving on to the definition of statistics. So it is nothing but a branch of mathematics, so which deals with collection, classification and interpretation of the data. So here statistics deals in three stages. The first one is collection of data. So first we need to collect the data. So this collection of data, so the first one is collection. So this collection of data is of two types. So the first one is primary data. So what is meant by primary data? So here the person, he himself collects the data and he will be doing the remaining process, right? So if a person directly get involved in collection of the data, then we call that data as primary data. Next, secondary data. So secondary data means if someone has collected the data and if we are using it, then such data is nothing but called as secondary data. In most of the cases, so we are going to use this secondary data, right? Because someone has written the book, or if you see the Google, so in the Google itself, so you are going to have lot of information, so which is collected by someone, but we are using that particular data. So hence that particular data we call it as secondary data, right? So after collection, so the second step is classification. So we are going to have the classification of data. So in this classification of data, so we can directly use the data, whatever the data that is obtained. So that particular data we call it as raw data. We call it as raw data, or sometimes it is called as ungrouped data. So by directly taking the data, so we are going to do something, right? So such classification we call it as raw data. And so there is, so if the data is large, if data is large enough, so that we cannot directly solve it by ungroup, so by ungrouped data or by raw data, so in such cases so we are going for grouped data. So that means we are going to group them together. So depending on the intervals or the situation, so we are going to group the data, and based on that we are going to do our interpretation. So here interpretation of data. So what is meant by interpretation? So interpretation means what you can tell about that data. So about that data, so what you can say, so which is nothing but we call it as interpretation. So to interpret about the data, so we are going to have the central tendency. So in this chapter, so we are going to discuss about the central tendency. So central tendency means nothing but, so we are going to find where the center of the data exists, so where the center of the data is present. So to find the central tendency we are having three tools. So to find the central tendency of a given data, so we are having three tools. So the first tool is nothing but mean, so which we call it as average also, right? So sometimes it is called as arithmetic mean. So this is the first measure of central tendency, and it is the commonly used measure of central tendency, right? So a common man can use this measure of central tendency, and it is commonly used in our day-to-day life, Right, next moving on to the second one. The second measure of central tendency is median. Next, the third one is mode. So these three are the main tools to find out the measure of central tendency. Right, so in this particular video, so in our 10th class, so we mostly depend, so we are going to discuss mostly on the group data. Right, so what is meant by group data first? So group data, so we are going to talk about group data. So this group data is nothing but the raw data. So whatever the data that we collect, so we are going to group them into class intervals. So that grouping, we call that particular table as frequency distributed data. We call it as frequency distributed or frequency distribution table. So the table we call it as frequency distribution table. Here in this table we are going to have the frequency distributed. So that frequency is distributed among the class intervals. Right. So we are going to have a class interval. Its corresponding we are going to have the frequency of that particular class interval. Right. So how this frequency distribution table? So what is meant by frequency? So frequency is nothing but the number of things or the number of people, so that belongs to that particular class interval. Right. So let for suppose if I consider an exam which consists of 50 marks and it was written by 40 students in a classroom. So there are 40 students in a classroom and it is for 50 marks. Then if you want, so you can take all the data. So one person got 50 marks, so one person got 49 and 48, 46, 4 people if they got, and likewise if you write down all the list of 40 people marks. So can you say, by looking at the list of these marks, so can you come to any conclusion? So can you say something about this data? So we can't directly say. Right. So if you want to look at the if you just look at the table and if you can say and if you can interpret the data, for that we are going to have the group data concept, which is nothing but frequency distribution table. So in this frequency distribution table, so what we are going to do is, so we are taking class intervals. So we are breaking the given marks into some intervals, and based on those intervals, so we are going to write down the number of students. So these number of students are nothing but we call them as frequency, and these class intervals are nothing but marks. So here these are marks and frequency is nothing but number of students. Right. Now this class interval, what I am going to do is, from 0 to 10 marks is one class interval, from 10 to 20 marks is one class interval, 20 to 30 marks is one class interval, 30 to 40 marks is one class interval, 40 to 50 marks is one more interval. Right. Now, so there is one more representation for class interval. So for suppose if I start from 1 mark, so 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. So these are two representations for the class intervals. Right. So in these situations, so 0 to 10, here 1 to 10, here 10 to 20, 20 to 30, 30 to 40, 40 to 50. So here if you observe, here in this classes, so this 1 to, so 0 to 10, 10 to 20, 20 to 30, 30 to 40, 50 to 40 to 50, these are nothing but called as class intervals. So here also these are all called as class intervals. But what is the difference between these two? Right. Now let us see. Here in this is class interval 1 to 10. So in this class interval 1 to 10, so this 1 is nothing but we call it as lower limit. We call it as lower limit, and this 10 is called as upper limit. Right. Now for every class interval you are going to have lower limit and upper limit, lower limit and upper limit. So in same way for all the class intervals you are going to have lower limit and upper limit. Here the upper limit of this class and the lower limit of next class are different. The upper limit of one class and the lower limit of the next class are different. So such type of classes are nothing but called as, so we call those class intervals as inclusive classes. We call those classes as inclusive classes. So why we are calling them as inclusive classes means, so here 1 to 10, that means 1 is included, 10 is also included, right? So such type of classes are called as inclusive classes. Next, here in this particular situation, so 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. So here in this situation, here 0 is called as lower limit, the same way how we are calling for this, the same thing. So 0 is lower limit, 10 is upper limit, 10 is upper limit, so 10 is lower limit, 20 is upper limit for this interval. For this interval 20 is lower limit, 30 is upper limit. So likewise we can consider for all the class intervals. But here if you observe, the the upper limit of one class is equal to the lower limit of next class. So such classes are called as exclusive classes. Such classes are called as exclusive classes. So why we are calling these as exclusive classes? So what is the main reason why we are calling it as exclusive class means, see here 10 has come 2 times, right? If for suppose if you are having a frequency 10, if you are having a mark 10, then in which class interval will you represent that 10? So here we are not going to represent in this class interval, we are going to introduce in the next class interval. So that means that frequency of 10 will be written here, right? So here what we are doing, this 10 we are excluding. So we are considering only from 0 to 10 without a 10. Here from 10 to 20 without 20. That means the rightmost value, that means the upper limit value we are omitting, excluding. So that's why we are calling it as exclusive class. Okay, next in this particular thing, so there come some situations where we are going to get some value in between 10 and 11. If we get any value between 10 and 11, then in such situations, so we cannot represent in inclusive classes. Can you represent the value in between 10 and 11 in any of the classes? So that means, so what happens, the data will be lost. So whatever the data that you are considering, so you are not taking in any of the class intervals. So in such situations you are not doing justification, right? So in those particular cases, so we need to convert these class intervals. So the class intervals which we call them as inclusive classes, we need to convert them into exclusive classes, right? So in such situations, so what we are going to do is, inclusive class I need to convert it as exclusive. So how can I do that? So what you are going to do is simply take the difference of these two. So difference of upper limit of one class to the lower limit of the next class. Just take the difference. So what is the difference? 1, and take its average. So average is nothing but, since we have taken difference of 2 items, no? So difference of 2 items is 1 by 2. So it is nothing but 0.5. So the difference, so here since the difference is 1 and its average is 0.5, so to change this class interval of inclusive classes as exclusive class, what we are going to do is, this particular 0.5 we need to subtract from the lower limit and add to the upper limit. Then these classes will become, so how can I write this as 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5, 30.5 to 40.5, 40.5 to 50.5, right? Now if you observe, the upper limit and the lower limit of the classes are equal, right? That means we can simply say these are exclusive classes. Now there is a difference between limits and a boundary. So what is meant by a limit? So whatever the things that are given, so those are nothing but called as limits. And to make it exclusive class, so when you make it as exclusive class, then we are going to get the boundaries. Okay, so for exclusive classes, so there won't be any change. For exclusive classes there won't be any change. So limits will be equal to boundaries. For exclusive classes limits are is equal to boundaries, so there won't be any change. Whereas for inclusive classes, so these are nothing but limits. So this is the lower limit, this is the upper limit. Whereas this 10.5 is called as lower boundary, this 20.5 is called as upper boundary. So lower boundary, upper boundary. So a new word, so you need to remember this, right? So lower limit and upper limit, lower boundary and upper boundary, right? So for exclusive classes there won't be any difference between boundaries and the limits, whereas for inclusive classes limits are different from boundaries. Okay, so limits will obtain for the given class intervals, whereas boundaries will be obtained for exclusive classes. So when we convert in inclusive to exclusive, then we are going to get this particular situation. Okay, next one more thing so that we need to recall here is about class mark. So class mark, or simply we call it as mid values. So other name for class mark is mid value. So this class mark or mid value is nothing but given by lower limit plus upper limit divided by 2. So simply what I can say, average of lower limit and upper limit. So it gives me the class mark, right? Next, moving on to the mean of grouped data. So we'll be talking about mean of grouped data. So mean of grouped data. So to find mean of grouped data, so we are having three methods. So to find mean of grouped data, we are having how many methods? Three methods. So first method is direct method. The second one is assumed mean method or deviation method, and third one is step deviation method or shortcut method, right? So there are three methods, so we will be discussing one after the other. The first one is direct method. So to find mean by direct method, so in direct method, so what we are going to have is, so we are going to have a simple formula. So mean, so this mean is represented by x bar. So this mean is equal to, simply what I can say, summation of f suffix I into x suffix I by summation of f suffix I. So this can also be written as summation of f suffix I into x suffix I by n, right? So this is nothing but the simple formula what we have. So we need to know each and every term. So what each and every term represents, right? Now here this fi represents, so fi represents the frequency of ith class interval or simply ith class. So here fi is nothing but we call it as frequency of ith class. Next xi is nothing but, so here xi, so previously we have discussed about the mid value, no? So here we have discussed about mid value, right? So this mid value is nothing but x suffix I, right? So which is nothing but lower limit plus upper limit by 2. The same thing here we are using it. So xi is nothing but mid value of ith class. So mid value of ith class means, so that particular class we need to consider lower limit plus upper limit by 2. Okay, so next finally what I am having, summation of fi. So summation of fi is nothing but represented by n. So here n is nothing but simply what we can say, sum of frequencies or number of observations. So simply number of observations. So it is number of observations or sum of frequencies. So sum of frequencies or number of observations, both are same. Okay, now so in this particular mean, so what we are using, we are going to make use of frequency and mid values. So these mid values are very, very important, right? So where we are using mid values, so mid values are used in mean. So to find out the mean, so we are going to make use of mid values. So direct method is one of the methods, so one of the appropriate methods, so which is used to find out the approximate value of the given so approximate mean value of the given data, right? So here xi, why we are considering the mid values? So mid values are nothing but the representative of a class interval. Okay, so so exactly at the middle of a class interval will be my mid value. So that's why we are considering the mid value as the representative of that particular data, right? Now how to do this method? So since we know the formula, so how to solve the problem? See, first of all, so in the question, so you will be given class interval and a frequency. So class intervals and frequencies are given in the question. So this is nothing but the format of the question that will be given in the examination. So using this data, so we are going to find out the mean. So how to write this data? So first of all, we are going to write down the class interval. So the question will be given horizontally and we are going to represent the table vertically. So first column will be written as class interval, and after that we are going to have the frequencies. So this frequency I am going to represent it as Fi, right? So the table is nothing but, so what we are going to do is, so what are all the terms that are there in the formula, so those terms we are going to represent in the table. Okay, so first class interval and frequency, these two will be given in the question itself. Next what we are doing is, so third column we are going to prepare. So what is that third column? So third column is nothing but of mid values. So mid values are nothing but xi. Mid values are nothing but xi. So this xi is obtained from class intervals, right? By taking the average of upper limit and lower limit, we are going to get the mid values, right? So from first, using the first column, we are going to get the third column. Next, using second and third columns, you are going to have fi into xi, right? So finally on adding, so finally I am going to get summation of fi xi. Next, by adding all the terms in the second column, we are going to get sigma fi. So since we know these two values, so directly on substituting in this formula, we are going to get the value of the mean, right? So this is nothing but the tabular representation for finding out the mean by direct method. So if you observe this table, so how many columns does this table have? So this table contains 4 columns. How many columns? 4 columns. Just remember. So I will tell you why. So just remember, so how many columns we have? 4 columns, right? Next, moving on to the second one. So the second method is assumed mean method, or so the second method is assumed mean method. So these methods are very, very important. So just understand the method, and after that we will go with the problem, then you will clearly understand. So first of all, you should know why we are calling the name of these methods, right? So assumed mean method or deviation method. So here the formula for mean, so the formula for mean is given by mean is equal to a plus, so sometimes you will be having capital A here, so in some books they will be representing with small a. So a plus summation of fi into di by summation of fi. So this can also be written as a plus summation of fi into, so this di I can write it as xi minus a by summation of fi, right? So this is one more representation for this. Now in this, so this is the formula we need to make use of, right? So here we are going to discuss about each and every point, each and every term. So what is fi? So already in the previous one we have discussed. So frequency of ith class or ith class interval. So here fi is nothing but frequency of ith class. Next, so already you know about xi. So xi is nothing but mid value of ith class. So mid value of ith class. So these two things already you know in the direct method. Next, here we are going to have so few more things. So in that first one is a. So what is a here? So a is nothing but assumed mean. So you are going to assume a particular value as mean, right? So this assumed mean is taken from mid values. So assumed mean is taken from mid values. So since you are going to get mid values, right? So among those mid values, any one of the value you can choose it as A. You can choose those values as A. After choosing the value, so directly you are going to find out the DI value. So what is DI? So the formula for DI is nothing but Xi minus A. The formula of DI is Xi minus A. So here Xi is nothing but mid values, A is nothing but assumed mean. Right? So Xi minus A. So using this formula, we are going to find out DI value. This DI is nothing but called as deviations. Deviation of ith class. So clearly this method is named as deviation method, or since we have considered assumed mean, so we can call it as assumed mean method also. Right? So what is the need for assumed mean method? So can't we directly go with the first method, direct method? So already you know, so the technology is advancing, right? So any new updation comes, that means it makes the work of human easier and faster, right? The same way here also. So the new methods will make the problem to solve in an easier way, right? So when my values are moderate, then we can use this method, assumed mean method, right? Next, when the values get larger and larger, then we are going for the third method, which we call it as step deviation method or shortcut method. Now let us see how this problem will be done, right? So already you know the first column is class interval. So first column will be filled by class interval and the second column will be filled by frequency. So frequency is denoted by Fi. Next, as earlier, so the third column is mid values. So mid values is generally represented by Xi. So by direct method, so whatever the things that you have done in the direct method, the same things you are writing here. First three columns will be filled as it is. Next, in the fourth method, in the fourth column, we are going to find DI value. So here DI is nothing but Xi minus A. So already we have written the formula, right? So DI is equal to Xi minus A. And finally, fifth column is Fi into DI. Fi into DI. Now you will be closing the table. So in this particular table, how many columns you got? So totally we got 5 columns. How many columns we got? 5 columns. So finally here in the last column you are going to get summation of Fi DI. In the second column you are going to get summation of Fi. So using these two and substituting in this particular, and A will be obtained from this Xi column. So from this Xi column we are going to get A value. So based on A value we are going to get the answer, right? So some may have a doubt. So what is this A, sir? So what is this A? So can we take any value? Yes, you can take any value of Xi as A. You can take any value of Xi as A. So if you take any value, the final answer, so whatever the mean that you are going to get, it will not change, but the values in the middle calculations may differ. Okay, so these two things you need to remember. And here how many columns we have? 5 columns. Just remember this. So in the previous one, how many columns we have? We have 4 columns in the previous one. Now we have 5 columns. Just remember method by method. Next, moving on to the third method. So the third method is nothing but we call it as step deviation method. We call this method as step deviation method, or simply we can call it as shortcut method. So this shortcut method is applicable for large values. So if you are having larger values, then you can use this step deviation method, right? So in this method, so we are going to have the mean formula. So mean formula x bar is equal to A plus, so it looks similar like assumed mean method. So just observe the condition, sigma Fi Ui by sigma Fi. So instead of Di you are going to get sigma instead of Di you are going to get Ui into, so here one more term will be multiplied, so that is nothing but h. So this h is multiplied only to the second term, not to the whole term. So what is the formula? A plus sigma fi ui by sigma fi into h. Okay, so this is nothing but the formula. So already you know about A. So A is nothing but assumed mean taken from the mid values. Next, Fi is nothing but frequency of ith class. Next, so we are having two more things. So already we know Xi is nothing but mid value of ith class. Next, A is nothing but assumed mean. So A is assumed mean taken from mid values. Next, so Fi is nothing but frequency of ith class interval. Next we are having Di. So what is Di here? So already Di is nothing but, already you know the formula, no? So Di is Xi minus A. So from this Di we are going to get Ui. So since in this formula we are having Ui, no? So Ui is nothing but Di by H. Ui is equal to Di by H. So Di again I can write it as Xi minus A by H. That means, so this Ui is nothing but Xi minus A by H. Ui is equal to Xi minus A by H. Next, what is H? So H is nothing but height of class interval. So height of class, or we can call it as class size. So height of class or class size. So how to find the class size? Simply take difference of two consecutive upper limits or two consecutive lower limits, right? So if you take difference of two consecutive upper limits or two consecutive lower limits, then you are going to get the class size, right? So this is nothing but the formula. Okay, so in this particular method, why we are calling it as step deviation method? So step deviation method, so you know about steps. So to climb this, so to go on to a house, so what you are going to do? So you need to climb on the steps, right? So steps will be uniformly distributed, right? So here also we are going to get the values in the form of steps. So while doing the problems, you can clearly see what those steps are. Okay, so there I will be recalling so what these steps meant, right? Now let us see the table. So how the table looks. So first we are going to have class intervals as usual, frequencies as usual, mid values as usual, and after that deviations as usual. So these four columns from the previous method. So we have these four columns. Next, fifth column is Ui. So already you know the formula. Ui is nothing but Xi minus A by H. So Ui is equal to Di by H. And after that finally the sixth column is Fi Ui. Now when you get, so summation of Fi Ui, here you will be getting Fi, and H will be calculated from the class intervals. So you will be substituting those values, and A will be calculated from Xi. So how many columns we have here? So totally 6 columns. How many columns we have? 6 columns. So from this what have you understood? So as the method changes, the number of columns increase by 1. The number of columns are increased by 1. Now 1 by 1. So in direct method, so formula is simple. So we are having 4 columns. In those first 2 columns are given in the question itself. Third column will be prepared by us, and fourth column will be getting by multiplying, right? So 4 columns. Next, for assumed mean method, you are going to have 5 columns. In step deviation method, you are going to have 6 columns. So these particular things you need to remember, right? So 4, 5, 6. So mean contains 4 letters. So simply remember 4 columns. And as the step change, so as the method changes, so you are going to have one more column being added up. Okay, so this is all about the brief introduction of group data for the mean. and these are the methods, so using which you are going to solve the problems, right? So thank you for watching the video. In the next video, so we are going to have the problems related to these mean, right? So thank you for watching.